So let's look at another example that we possibly use the fundamental fundamental counting principle, FCP. So in how many ways could a club select two members, one to open their next meeting and one to close it, given that Alan will not be present? So Alan is out of the loop. He's gone. So that leaves us one, two, three, four, five, six people. So six people there: Bob, Tim, David, Kathy, Evelyn, and Bill. So we have six people. So to open it, we have six people to choose from. That's our first event, if you will. Our second one would be to close it. So based on what I'm picking up on, the same person's not closing it. So to close it, we would only have five people left to close it. So that's the way I'm interpreting it. The same person's not opening and closing. So we have one to opening it and another person to close it. So we have six choices for opening and closing. So make sure I did that right. One, two, three, four, five, six, because Alan is not present. So what we'd have then is six times five would be 30. There would be 30 ways to make that happen. So let's look at another example, question 21. So I'm going to pause a minute and read the question. Okay. So in reading question 21, let's see if I can make this a little bit bigger. So a certain restaurant offers six choices in the soup and salad category, four soups, two salads, two choices in the bread category, and eight choices in the entree category. So find the number of dinners available if I'm choosing a soup, a salad, and one entree. So it looks like the bread is not being ch chosen here, just a soup, a salad, and an entree. So based on what I'm picking up on here, I have four different ways to choose a soup. I have two different ways to choose a salad, and I have eight choices in the entree category. So to me, I'm going to be doing four times two times eight. So four times two would be eight, and eight times eight would be then 64. So notice how, again, a calculator would not really be involved there. So that would be 64 different dinners available. So let's look at one more here, question 22. Again, I'm going to pause it for a second and read it. So question 22, a multiple choice test consists of six questions with each question having only two possible answers. So what we're trying to figure out is how many different possible ways can this be filled out? So if I have six questions, I'd have like question one, question two, question three, question four, question five, and question six. So I have six steps. I have to answer each question, but also I have two choices for question one, but also I have two choices for question two, two choices for question three, two choices for question four, two possible choices for question five, and also two possible choices for question six. And also we have two times two times two times two times two times two. So it's going to be one, two, three, four, five, six. That is two to the sixth power. So we could try to do this math by hand or just use a calculator. Two to the sixth power, that's going to give me 64. So if I look at this, I'd have like 4 times 2 would be 8, times 2 would be 16, times 2 would be 32, times 2 would be 64. So I am getting 64 there as I go across there. So how you write that math? Again, I kind of just felt like flowing down the page on that one. So 64 does match what they have there. So question 23 says, how many five-digit numbers are there in our system of counting numbers? So we could try to count them all, but notice how we do have the digits 0 through 9. So we have 10 different digits, but it doesn't make sense for the first digit to be a zero. So if I talk about digit one, digit two, digit three, digit four, and digit five, I only think there's 9 ways to choose digit one because we don't write a number with a zero in front. So that's going to be nine, but notice how digit two could be 0 through 9, so I have 10 choices there. Digit three would also have 10 choices. Digit four would be 10 choices because zero would be okay in those spots. And so I'd have 10 different choices for the last 4 digits. Just the first digit would have to be a 9. So remember, when you multiply by 10, that just means add a zero. So 1, 2, 3, 4 tens. That just means a 9 and 4 zeros. So that would be 90,000 numbers if we did that. 90,000 numbers. And again, you could list them if you wanted to think about it and go from there.